ones and the pairs with the pairs. Now we're gonna try to combine like terms. It's really very easy, yeah, it's something you can learn. When you wanna do it, you look at. Hello and welcome to the Kearney Math Show. Thank you all for tuning in today. On today's episode of the Kearney Math Show, we are going to be featuring simplifying variable expressions, and this is entry number 3. So take a moment to write entry 3 at the top of your paper. All right, so by the end of today, guys, our learning goals, I want you to be able to identify like terms, and I want you to be able to simplify expressions by using the distributive property and combining like terms. So let's just dive right in and start with one of those things I just said, which is the distributive property. Now, some of you probably have seen this in the past. The big difference from what you've done in the past with distributive property to 7th grade is we're dealing with positive and negative numbers now. So the distributive property is exactly what it sounds like. You're distributing a number. So we're at the top. The distributive property means to multiply a sum or difference. Multiply each number within the parentheses by the number outside of the parentheses. Okay, so if we consider the problem 2 times x plus 4, that, if we were to talk about what that means, that actually means there are 2 groups of x plus 4. So if I were to write that out, that would mean I'd have x plus 4, and then plus another group of that, which would be x plus 4. Okay? And then we could combine like terms. We have an x plus another x, which would be 2x. And then we have 4 and 4, which is positive 8. So it works out that you could just write out what you're multiplying, but there's a more efficient way, because if you had 10 times x plus 4, you're not going to want to write out x plus 4 10 times. So there's a more efficient way, and to do that, what you're going to do is you're simply going to take the number on the outside of the parentheses. So let's say that you had negative 3 times x plus 5. Okay, you're going to just simply take that negative 3, and we're going to distribute or multiply it by everything on the inside. Okay, so over here, we take 2, and we're multiplying it 2 times x, which we get 2x, and then 2 times 4, which is 8. Okay, so if we were to consider this new example over on the side, negative 3 times x. So negative times a positive is a negative, so we would have negative 3x. And then since that 5, if you notice in front of it, there's a plus sign. So we're going to treat that 5 like it's a positive. So that's a negative 3 times positive 5, which a negative times a positive would be a negative, and 3 times 5 is 15. So that would be minus 15. Okay? So to do the distributive property, you're simply going to take that number on the outside and multiply it by everything on the inside, and just pay close attention to those signs, okay? And we're going to do some more of those together when you come to my station, all right? So now let's go down to what we need in order to combine some like terms, because we said our goal was by the end of today to be able to simplify by using distributive property and combining like terms, okay? So let's just talk about that term, that word term. A term can be several things. In variable expressions, terms are separated by addition or subtraction signs. So if you have this example here, we've got A is a term, 2B is a term, 5C is a term, and 6 is a term, okay? And if we were to look specifically at, for example, that 2B term, that number that is multiplied by the variable, that 2, right there, that is called the coefficient. And you say coefficient. Okay? That number that you are multiplying the variable by in front is called the coefficient, or as I like to say, coefficient. Okay? So now, terms can be several things. A term could be one of the things we talked about yesterday, a number by itself. And if you remember from yesterday, we called that a constant. Okay, constant, a number by itself because it doesn't change. It's 5 is always going to be 5. Okay, or a term could be a variable, which we also talked about yesterday. Remember, variables can be lots of different letters or symbols that hold the place for a number. Or a term could be one of a combination of the two, where it's a variable and a coefficient multiplied by each other. So, for example, 3m is a term because you got 3 and you're multiplying it by m, and that 3 is, like we said, the coefficient. Okay? So now, if we were to take it a step further and not just talk about what are terms, but what are like terms, so that we can combine them. So, just like you heard in the video, like terms, you put the apples with the apples and the pears with the pears. Like terms have to be very, very much alike. Their variables have to be identical. Okay? But the very first like term is a constant. All constants are like terms. So if you have a number by itself, 5 and 7 and 23 and negative 13, those are like terms because you can combine them. Okay, they're just numbers. So constants are like terms. But if you have a variable included, then like terms have to have identical variables with a raised power that is exactly the same. Okay, so for example, 2a, 3a, 9a, a, they're all like terms because they all have that identical variable of a. Okay? Underneath that, 9x squared, 4x squared, 18x squared, they're all identical because they have the like term of x squared. Okay? Now, if you had a 5x, you could not combine that with x squareds. Remember, the powers have to be the same. The variables have to be identical. Okay, so what I want you to do is I want you to take a minute and you're going to take this list, if you'll pause the video, and you're going to take this list and you're going to try to sort those out into like terms. So you're going to have your x terms, your y terms, your constants, and your b terms. So quickly, just pause the video and fill those in and separate those out, okay? So go ahead and pause the video and separate those. Okay, so let's check to see if you got it right. So our x terms, we got 3x, 5x, x, and 4x. For my y terms, I got 9y, 6y, and y. For my constants, remember constant's a number by itself, they're like terms, I got 7, 6, 3, and 5. And then for my b terms, I got 4b, 10b, B, and 2B. Okay? So, just to recap, we said distributive property was you're taking the number outside of the parentheses and multiplying about everything inside. And then we said like terms had to have identical variables and their powers had to be exactly the same. Okay? So, let's take those two concepts and put it together to do some fun math. Okay? We are going to start tackling some pretty complicated expressions. And we are going to be simplifying them, okay? So we're going to try to simplify these expressions using 3 easy peasy steps, okay? Step 1, what I want you to do is I want you to look at the expression and determine, can you use distributive property, okay? So we're going to look at example 1 right here, and we're going to use these 3 steps, okay? So example 1, we're going to see if we can use distributive property. Do you see any parentheses that we could use? Yeah, so we're going to distribute that 3. And remember, you're only distributing it to what's inside the parentheses, not the whole problem, because you're only multiplying that x minus 3 times 3. Okay, so if we were to multiply, 3 times x is 3x, and then 3, and we're going to treat that as a minus 3, so treat it like a negative. So positive 3 times negative 3 is negative 9. Okay? Now we're just going to bring down the rest. So step 1, use the distributive property when necessary. Check. Step 2, we're going to identify the like terms. So for me, I use shapes to help me identify like terms. And when you identify like terms, something super important is you want to make sure you include the sign in front. So for example, 3x, what is like 3x? 2x, but you got to include the sign. So what do we treat the 2x like? What goes with the 2x? Plus 2x. That tells me it's positive 2x. Okay? Now I'm going to maybe pick a different shape to show my other terms. So I might do a square. Okay? What is like negative 9? What's a like term to negative 9? That 8. And what do we have to include with the 8? The sign in front. Okay, so step 1, we use distributive property. Step 2, we have used shapes to identify the like terms. And then our third and final step is to combine those like terms. Okay, so we have 3x, positive 3x and positive 2x. That would be 5x. And then we have a negative 9 and a positive 8. So are the signs the same or are they different? They're different. And so I'm going to subtract 9 minus 8. And there are more negatives there, so it would be minus negative 1, which is minus 1. Okay? So to recap what we just did, we went through and we looked to see if we could use the distributive property. Then we identified the like terms. And then we combine them. And you remember when you're identifying like terms, you want to make sure you include the sign in front. Okay? So if you will take this time to go through and start the next couple of practice problems and continue to work, and you can check the answer key as you go. All right. Good job, guys. Make me proud. Peace out, Rainbow Trout. Love you, mean it.